Imagine you're engaged in a game. After a while, you might take a step back and reflect on the rules in the game that you have to follow, or why you're participating in this game in the first place. This self-reflection process aligns with a sense of truth and points to a deeper level of understanding. When you step back and thinking about your own thought processes, you're no longer bound by the rules in the game. But what causes you to think in such a way? This reflection touches on a fundamental question. Why do conscious beings seem to have the ability to step back and contemplate? How do you imagine things beyond the game or anything similar in daily life that follows certain rules? The answer lies in our grasp and awareness of what that game really is. Understand the rules themselves. This quality of understanding, the examination and reflection of our own experiences, is called introspection. It's not bound by any rule and cannot be calculated. It's beyond computation. It's the defining feature of human consciousness. It's the ability of a conscious being to reflect on its own thoughts, emotions, and experiences. It involves a self-reflective process where the mind turns inward to examine its own states. Consciousness is not just the result of complex computations performed by the brain, but rather involves processes that goes beyond traditional algorithmic computations following predefined set of rules, procedures, or calculations. And introspection plays a crucial role in illustrating that non-computational aspect. This ability to step back and consider one's own mental processes is the signature of human consciousness. It's a deeply subjective experience that involves awareness not just of the physical world, but of one's internal mental state. Traditional computers, which operate on fixed rules and algorithms, lack the ability to introspect. They cannot step outside their programming to reflect on or alter their own operations in a meaningful way. Human introspection allows us to grasp truths and understand concepts that go beyond following rules. For example, when a mathematician grasps a new theorem, they're not just following a set of rules. They're engaging in a form of understanding that involves creativity and insight, processes that are believed to be non-computational in nature. In the game example, understanding why the rules give us truth enables us to surpass or go beyond the rules themselves. This understanding, whatever it is, somehow involves consciousness. The game player can't comprehend the game if it's unaware of its existence. This is the quality of conscious experience. Consciousness can go beyond any rules because it exists beyond them. Computational and non-computational are two broad views about the nature of consciousness, how it comes into being, and how it can be understood. Consciousness, based on computational theory, can be explained in terms of computational processes in the brain. The brain does information processing analogous to a computer, and consciousness emerges from these computing mechanisms. This means that consciousness might be understood and replicated through computational models. Non-computational theory says that consciousness can't be fully explained or replicated through computational processes alone. The theory says that there are aspects of consciousness, like subjective experience, that can't be captured by computational models. Consciousness might arise from non-computational processes, or it involves elements that are beyond the scope of computation. Going back to math example, the ability to understand allows mathematicians to go beyond any specific set of rules they use for proving mathematical concepts. Artists create innovative and original works that go beyond conventional techniques and rules, doing art with their intuition and inspiration rather than predefined algorithms. Human consciousness, particularly in areas like mathematical understanding, goes beyond algorithmic processing. While a computer follows a set of predefined rules to solve mathematical problems, a human mathematician can often see the truth of a concept intuitively without relying strictly on step-by-step computational procedures. This ability to grasp the essence of a mathematical idea or to understand the relationships between concepts is not something that can be easily replicated by a machine following fixed algorithms. People often make complicated ethical decisions that cannot be reduced to a simple set of computational rules. Imagine a moral system, a set of principles or rules that guide what is considered right or wrong in every possible situation. This system is intended to provide clear moral judgments for any ethical dilemma. Now imagine a moral dilemma that the ethical system struggles to resolve. The classic trolley problem is a good example of this, where a trolley is headed toward 5 people on the tracks, but you have the option to divert it to another track where it will only hit 1 person. The system might have rules like, it's always wrong to kill an innocent person, but also, it's always right to minimize harm. The problem arises when these principles conflict. Should you act to save 5 by sacrificing 1, or avoid acting altogether to avoid directly causing harm? This moral system may be internally consistent, covering most situations, but in certain complex dilemmas it might reach a point where it cannot provide a clear or definitive answer. There may be situations where no action seems morally justified, or where different moral principles lead to contradictory conclusions. These situations are true but unprovable statements, ethical truths, or judgments that the system recognizes but can't resolve within its own rules. The ethical system is incomplete because it can't provide the moral resolution to every possible dilemma. So the non-computational nature of consciousness, a form of understanding that involves insight, creativity, and intuitive grasp of truth, can't be fully explained by computational models. The comprehension that game players, mathematicians, or artists hold doesn't follow or abide by the rules. It goes beyond them. What is it about consciousness that grants this advantage? There's something more here. What this shows is that there might be more to uncover about the nature of consciousness and its role in our understanding of the world. Seems like there's a gap in the existing theories. If consciousness or understanding is not computational, what is it then? Our ability to think introspectively points to a unique aspect of consciousness that cannot be fully explained by classical physics or traditional computational models, and might have a deeper quantum mechanical basis. Classical physics deals with the laws of motion and energy that we can observe in everyday life. Quantum physics explores the strange behaviors of subatomic particles, where things can be in multiple states at once and can act like both particles and waves. Essentially, while classical physics explains the world we see, quantum physics reveals a more complex and often counterintuitive underlying reality. Internal conscious experience could be a kind of quantum reality. The brain cell or neural activities, especially those related to consciousness, may involve some quantum effects. These effects could play a role in explaining the mind's ability to process information, perceive the world, and generate conscious experiences. The best way to perceive this is to imagine a cloud representing a space where you might find an elementary particle like an electron. The cloud demonstrates how electron can be in many places at once, but there are certain areas where it's more likely to be found, like the wider areas, and areas where it's less probable to be found, like the darker areas. It's impossible to predict the exact outcome of any measurement. What quantum mechanics has to offer are probabilities. Until a measurement is made, the system is not in a definite state, but rather exists in a superposition of all possible states. This superposition is described by a mathematical description called a wave function. It contains all the information about electron's state, including its position, momentum, and other properties. After the measurement, the particle seems to end up in one fixed state, a quantum phenomenon known as the collapse of the wave function, or the reduction of the state. In the context of classical physics that describes the world in the macroscopic scale of humans, planets, and galaxies, we perceive objects as singular entities rather than multiple possibilities simultaneously because of the wave function collapse. When observed with the naked eye, objects appear as definite, singular entities. The collapsing process is fundamentally random but influenced by probabilities. This is what Einstein famously compared to God playing dice to determine what turns out to be real and what we observe in our classical world. On one side we have the superposition of a particle, the quantum realm. On the other, there's the familiar classical reality, where things exist in a single definite state. Wave function collapse is like a bridge connecting the realms of quantum and classical realities. This is the relationship between quantum and classical physics. The question of what triggers the collapse of a state's wave function stays open in quantum physics, the measurement problem in quantum mechanics. It's been argued that consciousness impacts quantum effects, that it somehow influences quantum particles, a phenomenon known as the observer effect. The speculation is that consciousness itself might play a role in the wave function collapse. The act of conscious observation, rather than any physical interaction or measurement, might be what causes the quantum state to resolve into a definite outcome. There's an alternative view that's the exact opposite of the observer effect. Consciousness depends on the wave function collapse. The wave function collapse is not caused by the conscious observer. Rather, it's an inherent process related to the nature of consciousness. It's not a conscious observer that causes the reduction. Rather, the state itself reduces in some way, transitioning from a superposition of possibilities to a specific outcome. When this occurs, an element of proto-consciousness comes into play. Proto-consciousness is the fundamental building block from which actual consciousness forms. It can be thought of as a basic form of awareness or potential consciousness that emerges during the collapse of the quantum state. The act of selecting an outcome might involve some level of proto-conscious awareness, which then lays the groundwork for the emergence of actual consciousness. This is what's known as Orch OR, short for orchestrated objective reduction. Consciousness in this theory is a quantum effect that emerges at the quantum scale. It's the physical mechanism necessary for consciousness to occur. It arises from quantum computations in the brain, which could influence how wave function collapses in a way that is orchestrated or organized, hence the name orchestrated objective reduction. Objective means that it's a physical process. Reduction stands for the wave function collapse. Objective reduction is the part that we experience. The orchestrated is the most mysterious part. How does the brain coordinate different individual processes to form a coherent conscious experience? At the moment of consciousness, the emergence of the chosen fixed reality is seen as if it has always been the case, even though it's only defined or realized at the moment of collapse. It's as if the collapse of the wave function reaches back in time to determine the state of reality, even though according to quantum mechanics, the state of reality was uncertain or in a superposition of states before the collapse. This mysterious phenomenon is known as retroactivity. We may on some level be conscious of all possible realities that are retroactively annihilated. Experiments demonstrate that the collapse instantaneously reduces multiple quantum states. Even the concepts of before and after could be nonsensical in quantum reality due to different phenomena, including superposition, particles existing in multiple states simultaneously until measured, which complicates the notion of a clear sequence of events. Non-locality, particles instantaneously connected regardless of distance, another quantum fact known as entanglement that challenges our classical understanding of causality and timing. And time, the fact that time may not be a fundamental component of reality in the way we typically understand it. Before a decision is made between, let's say, two possible actions, the brain can exist in a quantum superposition where those two actions are simultaneously present. This occurs at an earlier stage in the brain's processing. When you make a decision, it retroactively eliminates, meaning jumps back and overwrites multiple quantum possibilities, creating the impression that there was always only one definitive choice. Classical fixed reality emerges retroactively from the collapse of the quantum wave function. Superpositions, based on Orch OR, are coordinated by protein filaments within brain cells or neurons known as microtubules. These orchestrated vibrations, meaning variations in the state of the microtubules, entangle together, process information, and terminate in the collapse of the wave function, leading to a series of Orch OR moments. The process is theorized to give rise to moments of conscious insight and deeper understanding, setting human consciousness apart from other forms of information processing. The non-computable or non-algorithmic moment in the brain, the wave function collapse, reduces the superposition of many states into one fixed state, the measuring process in quantum mechanics. That's when conscious awareness, the orchestrated conscious experience within the brain, kicks in. This reduction or collapse is thought to orchestrate cognitive functions in a way that allows for the rich, subjective experience of self-reflection and awareness. For any quantum particle to maintain its superposition, quantum coherence needs to be maintained. Any interaction with the environment causes decoherence, which causes the superposition to collapse. Many scientists argue that the brain's warm and wet environment makes it unlikely for quantum states to influence neural activity, because quantum coherence typically requires highly isolated and cold environments. The symmetrical structure of neuron microtubules could effectively preserve quantum coherence, preventing it from leaking into the surrounding environment. In the Orch OR framework, introspection could be seen as a direct manifestation of quantum processes. When we introspect, meaning thinking about our own thoughts and feelings, we might be accessing a deeper level of consciousness that are influenced by quantum states. This process is inherently non-computational, because it involves the reduction of quantum states that can't be simulated or predicted by classical algorithms. The ability to introspect is linked to human creativity and the ability to understand complex concepts. It's not just about processing information or running computations. It's about experiencing awareness in a way that involves quantum level phenomena. which are beyond the scope of conventional computational theories of mind. There's an objective phenomenon that causes the wave function to collapse. One speculation: gravity. Gravity is a key factor in classical physics that's absent from quantum mechanics. Each state in quantum superposition may sense the others through their gravitational interactions. It's as if this attraction makes the object measuring itself, and the act of measurement triggers the collapse. In the context of classical physics or Einstein's general relativity, a superposition of localities deforms the fabric of spacetime in multiple ways at once, a situation that general relativity cannot account for. This has been illustrated as a clash, in which quantum mechanics will bend before general relativity does. A gravitational field can't exist in a quantum superposition, and that results in the collapse of the particle's wave function. Gravity-induced wave function collapse reverses time, retroactively erasing possible quantum realities in less than a second. This backward elimination of realities gives the illusion that only one fixed classical reality has ever existed. This reflects the influence of gravity on quantum mechanics. Each gravity-induced collapse generates a small spike of proto-consciousness. Orch OR has been met with skepticism from the scientific community due to its departure from mainstream neuroscience and quantum physics and the lack of direct empirical evidence. The theory begins with the assertion that consciousness is not a product of computation, and that extends beyond the insights provided by neuroscience, biology, or physics. Critics argue that while the theory is intriguing, it needs more research to demonstrate how those quantum processes could give rise to the introspective capabilities observed in human consciousness. Some researchers believe that introspection can be explained by more traditional neurological processes without invoking quantum mechanics. They argue that complex neural networks could, in theory, simulate introspective experiences, even if they do so in a computationally intensive way. The majority of scientists view quantum mechanics as irrelevant to our understanding of brain function. Critics argue that linking strange phenomena in quantum mechanics to consciousness lacks sufficient scientific support. Proponents of Orch OR, on the other hand, believe that measuring the wave function collapse is the most important experiment anybody should be working on. And yet, there aren't many. The good news is, Orch OR is falsifiable. There are three primary hypotheses for experimental testing. 1. Gravity causes the collapse of the wave function, a core aspect of the theory, implying that gravitational effects play a role in quantum state reduction. 2. The collapse includes retroactivity, meaning the effects of the collapse may influence past states, a more speculative element of the theory. And 3. Consciousness emerges from this process, the fundamental claim of the theory, suggesting that consciousness is a product of these quantum processes. Orch OR invites objective experimentation and observation from various scientific disciplines, including neuroscience, quantum mechanics, and theoretical physics, like examining whether microtubules indeed demonstrate the predicted quantum behavior under specific conditions, or if altering microtubule function affects consciousness in expected ways. If we go back to the wide spectrum of theories reviewed in previous episodes, ranging from purely physical to more metaphysical, the speculation could be that Orch OR belongs under the category of emergentism, the idea that consciousness arises as a complex phenomenon from simpler processes in the brain, a case in which consciousness is not a fundamental property or substance, but rather a result of the interaction and organization of simpler, non-conscious elements. But that's not the right category. Orch OR offers a specific mechanism for consciousness that involves quantum processes in the brain's microtubules. While Orch OR does suggest that consciousness emerges from the complexity of quantum processes in the brain, it does so in a way that implies a fundamental role for these processes, which are not just emergent properties of simpler components, but rather intrinsic aspects of how consciousness arises. This distinction implies that although Orch OR is in line with non-reductive physicalism, the idea that consciousness is fully dependent on and arises from physical processes in the brain, it can't be completely reduced to or fully explained by these physical processes. There's an aspect of our conscious understanding that exceeds computational limits. Given that all physical theories are computational, there must be a process in the reduction of quantum states that leads to a non-computational understanding. Something fundamental is missing. The part of the theory that can't be put on a computer. The gap might not be about how we understand quantum mechanics, but rather in the theory itself. How could the collapse of the wave function caused by gravity result in non-computational consciousness? It seems like consciousness goes beyond the current quantum theory. According to the creator of Orch OR, the Nobel laureate Sir Roger Penrose, quantum mechanics might need modification. It has to make room for understanding. So essentially, as Penrose claims, we need a new scientific discipline that hasn't yet been established. We could be far from grasping the nature of what is happening, mainly because we lack a complete understanding of the physics involved. So will we ever develop the ultimate theory of consciousness? We might, but according to Penrose, we're far from achieving that. Assuming this is the right approach, consciousness should be included in physical theories, and those theories might be able to offer an explanation for what consciousness really is. Non-physicalists, the group that see consciousness as metaphysical, fail to provide convincing arguments regarding the non-physical elements of consciousness. We have no solid basis for dismissing physicalism, the philosophical theory that claims everything is ultimately physical in nature. It remains the only theory that offers some hope in our understanding of consciousness and its nature. Our experiences and consciousness, according to physicalists, are not separate from the material world. They're part of the same fabric of reality, deeply rooted in the physical universe. The laws of physics seem nonsensical at subatomic level, where the smallest particles follow different principles, quantum mechanics, than those governing the world around us, classical physics or general relativity. This gap creates a division between two distinct forms of reality. The search for a theory of everything continues, a framework famously known as quantum gravity that will eventually integrate gravity into quantum mechanics and hopefully connect those two theories, quantum mechanics of the microscopic and general relativity of macroscopic world, into a single unified theory, an endeavor that started with Einstein and still continues to this day. The physical process linking these two realities might have the potential to eventually reveal insights into the mystery of consciousness.